There we go. Okay, hang on. We have a couple of people who can't hear us. Alrighty, so let's go ahead and start back into that. So we've got the x-axis, that's the horizontal portion of a graph. Typically used to graph the input of a function, and that's things that you could count. My favorite example for explaining to people why you want to use some kind of graphing tool would be to show how much you're earning each week from a paycheck. Especially if you have a job where you don't get a solid 40 hours every week. Sometimes you might have, 38 hours, sometimes you might only have 35 hours. You want to figure out how much money you're making each week. So the thing that you would count would be your x-axis, would be the number of hours that you worked. And then you would take that number of hours and you'd multiply it times your pay, and you would add whatever kind of base pay you might have. If you have a sales job and you get commissions or something, you would add that, and then you would get the output, which is what you would put on the y-axis. And it's the vertical portion of your graph. And again, it's typically used to graph the output of a function. Your y-intercept is the point of your graph where the graph line crosses the y-axis. The x-intercept is very similar, except that's where your graph line crosses your x-axis. And a slope is the number that's used to describe the change in your graph line. Specifically, that's the change in y, or how much your graph rises over how much it changes in x, or how much it runs to the right. And we'll see some more of that as we go through the exercises here tonight. So let's go ahead and get cranking and start off with the first demonstration here. Here we have a word problem. We're going to use the information they give us to graph the line. They say the sugar sweet company is going to transport its sugar to market. It will cost $6,075 to rent trucks, and it will cost an additional $225 for each ton of sugar transported. Let C represent the total cost in dollars, and let S represent the amount of sugar in tons transported. Write an equation relating C to S, and then graph your equation using the axes below. Again, so we've got a couple of axes already drawn. Here we have an x-axis and a y-axis. The thing that we're counting here is the tons of sugar that's being used. And so that's going to be along our x-axis. And so I'm actually going to call our x-axis S tonight, or for this example at least. Why am I not? Oh, shoot. You guys can't see my screen. Hang on one second here. Sorry, I spent the last 9.5 hours fighting with some brake rotors in my car, and I'm kind of tired, so I apologize for so little mistakes like not sharing my screen and any horrible math mistakes I might make in advance. Okay, can everyone see my screen now? Okay, one more second here. There we go. Okay, well, I already read the problem out loud for you guys. So again, I've got these axes over here. I'm going to label them. So we've got S is going to be the amount of sugar in tons. I already clicked on brushes. Why isn't this working? There we go. And then C is going to be my output. That's going to be the cost in dollars. Now it says that we're going to need to write an equation relating C to S. We need something that says, hey, C equals something in terms of S. So I know I'm going to have C on the left and something going on with S on the right. We know that it's going to cost initially $6,075 to rent the trucks, and it's going to cost an additional $225 for each ton of sugar. So if each ton of sugar is 225, then we're going to multiply this 225 times the number of tons of sugar that we have, because that will tell us what our cost is going to be. So we've got 225S plus our initial cost just to rent the trucks, $6,075. And here we've got the basic formula for a line, where here we have our slope, is the number times our variable. And over here we've got our y-intercept. And if I try to graph this, I'm not going to try to make all the different ticks. We're just going to go ahead and say that this is going to be our starting point. It's going to be our y-intercept, right where we haven't put any tons of sugar on the trucks yet. Right now we've just rented the trucks, and that's our only cost, and that's $6,075. And then if we say that this is for 1 ton of sugar, 2 tons of sugar, 3 tons of sugar, so on and so forth, we would get a line of variance there. And if we just do 1 ton of sugar, then we have 1 going in for our S, so we have 225 times 1 is 225, plus the 6,075 would be 6,300. So I'm going to put a point right here and say that that is 6,300. And if we go along to our 2 tons of sugar, we put that in for S. We have 2 times 225 is going to be 450, plus the 6,075 is going to be 6,525. So I'm going to put another little point right here and say that that's my 6,525. And I can keep going for infinite amounts of sugar, but we can get the general pattern here just off the first ton of sugar, but especially where we have 2 tons of sugar. Why isn't there we go. And so we see that we just have a line going up constantly like this. We could just keep adding more tick marks every 225, and it would correlate to the tick marks down here for each ton of sugar. Does that make sense to everyone? Good. I'm going to go ahead and pull up a practice problem then. Let's take a look here. Here we go. So we've got the owners of a recreation area are going to fill up a small pond with water. They're adding water at a rate of 30 liters per minute, and there are 700 liters in the pond to start. We're going to let W represent the amount of water in the pond in liters, and T represent the number of minutes that water has been added. Write an equation relating W to T, and then graph the equation on the axis to the right. Again, figure out what you're counting first. That's going to be the variable on the right-hand side, and then the other variable is going to go on the left, and write your equation accordingly. I'll give you guys a minute or two to work through this, and I'll come back and check on you. Feel free to ask any questions that you have in the chat box. Okay, does anybody need any more time for this one? Just type a Y or an N into the chat box, please. All right, so as Don pointed out, we have our initial equation here, which is just going to be, we're going to have W on the left, the amount of water in the pool, because the thing that we're going to be counting is time. And we had 700 pools to start, and we're adding 30 liters per minute. Since per minute is our time, then we're going to have 30 times T plus 700. And if we come over to the graph, we're going to make a starting point and call that 700. And then after the first minute and second minute, we're going to have 730 liters for 1 times 30 plus 700. And 760 liters for 2 times 30, which would be 60 plus 700. And we can plot our points and line accordingly. So at the very starting point, we only had 700 liters in the pond. We haven't added any water yet. After 1 minute, we've added 30 liters. After 2 minutes, we've got another 30 liters for a total of 760 liters. And we can plot our line going up like that. Does it make sense for everyone? Good. Let's go ahead and crank on to number 2 then. So in this one, we have the monthly cost in dollars of water use is a linear function of the amount of water used in hundreds of cubic feet. Cost for using 100 cubic feet of water is $35.87, and the cost for using 5,300 cubic feet is $75.02. What is the cost for 3,600? So in this case, we would need to be able to make a function that shows the relationship between the starting point and the ending point here. So basically, we've been given 2 coordinate points here where we have x is 24, our y is 3587, because we're counting the hundreds of cubic feet of water. And that x is 53, we have $75 or $75.02. So here we can use the same equations we were using last week, where first thing we're going to do is find out what our slope is, where we have m, which is our slope, is equal to the change in y, or y2 minus y1, divided by the change in x, which is going to be x2 minus x1. So we can use the points 75.02 minus 35.87 divided by, since I use 75.02 first, I need to use the x that goes with that one first and say 53 minus 24. And I forgot to grab my calculator. I believe that's going to give us 39.15 over 19, or sorry, 29. If I did any math wrong, please point it out, but I'm pretty sure we can go along with that. So now we have our slope, sorry, that's equal to m. Now we can use the formula y minus y1 is equal to m times x minus x1. Oh boy, I'm really going to want a calculator in a second here. I might have to run and grab mine real quick. We can grab either one of these points to fill in for x1 and y1. I'm just going to grab the top one because that's kind of convenient in a way. I don't know. So we have y minus 35.87 is equal to 39.15 over 29 times 20, or x minus 24. I am definitely going to want to grab my calculator. Hang on one second, please, while I go do that. Okay, sorry about that. So on the left side, we've still got y minus 35.87 is equal. Actually, I'm going to save us a quick step here. We could go ahead and continue this out and get our generic line formula first. But since we know that we're going to be plugging in an x value, specifically this 36 up here, we can go ahead and plug that in now. And put that in for 39.15 over 29 times 36 minus 24, which is going to be 12. So that gets to y minus 35.87, whoops, is equal to 39.15 over 29 times 12. So we have, y minus 35.87 equal to, and I'm going to go ahead and do that in my calculator. So 39.15 times 12 and divided by 29 is going to give us 1620. Which seems like a nice, convenient number to work with. Add 3587 to both sides. And we'll get the y is equal to 5207. So when we have 3,600 cubic feet of water, it would cost $52.07, which seems about right because 36 is a little bit more than, or is a bit more than 24. 52 is a bit more than 35 that goes with that. 36 is less than the 53, and 52 is less than the 75 that goes with that 53. So it's about right in the middle there where it belongs. Does that make sense to everyone? All right, well, I'm not seeing any arguments here, so let's go ahead and pull up the second practice problem. I'll let you guys crack at this. Again, type in any questions into the chat box. I'll be watching, and I'll get right back with you guys in a minute or two. Okay, does anybody need any more time? Alrighty. So again, we've got a situation here where we're going to start off with finding our slope. We're also going to write down our two coordinates real quick just to be on the safe side. When carrying 10 gallons of fuel, the airplane weighs 2,162 pounds. When carrying 25 gallons of fuel, it weighs 2,255 pounds. So how much does the airplane weigh if it's carrying 35 gallons of fuel? So when we have 10 gallons, we had 2,162 pounds. When we had 25 gallons, weight was 2,255 pounds. This must be a really small plane. So our initial slope is going to be, M is going to be equal to 2255 minus 2162 over 25 minus 10. And that's going to be equal to 2255 minus 2162. I get 93 gallons, or 93 pounds per 15 gallons of fuel. So now we can use that point slope formula again, where we have y minus our y1, I'm going to say 2162, is equal to our slope, m, times x minus x1, which would be 10, that goes with that 2162. Again, I can plug in, they're asking what it is at 35 gallons, so I can go ahead and plug that in for this x. So that I get y minus 2162 is equal to 93 over 15 times 35 minus 10. Or y minus 2162 is equal to 93 over 15 times 25. Go ahead and multiply that out, and we should get 155 on the right. Add this 2162 to both sides. And we will get to 2,317 pounds. Is that what everyone else got? So for the 93 over 15 times 25, I did 93 times 25 and then divided by 15. I just typed that into my calculator. And when I did that, the calculator spat back the 155. Okay. All right, let's go ahead and go on to problem number 3 here. So here we're looking for domain and range. To define this at the beginning, domain is going to be whatever values on our graph that can be represented by x. So any x values that exist in our graph or in a set or relation. Range is just going to be the corresponding y values. So here we're going to suppose that we have a relation h that is defined as follows. When x is 1, y is p. When x is 1, y is m. And when x is 5, y is n. So the domain for this relation h is going to be all of our x values, which in this case is just 1 and 5. We're going to do some set notation, so we're going to include these little curly brackets here. And our range is going to be all the y values, which is, in this case would be P, M, and N. That's it. Pretty quick and painless, I think. Does that make sense to everyone? All right, I'm going to go ahead and pull up the practice problem, give you guys just a few seconds to work it out, because again, these really aren't too long. And I'll be back in 20 or 30 seconds. Okay, does anyone need any more time? Alrighty here, so let's go ahead and start off with our domain for S. And that's going to equal, it's a really ugly curly bracket, sorry about that. Our X values in this case are 3 and 6. And for our range, we're going to plug in our Y values, and we'll get A, C, and B. Anyone get anything different? All right, good. Let's go ahead and jump on to problem number 4 then. The entire graph of the function h is shown in the figure below. Write the domain and range of h using interval notation. So as I said, the domain and range are really, the domain and range are really just the values that correspond to the graph on the x and y axis. So for domain, we're going to just take a look at how far it goes left and right, where it starts and stops. And in this case, all right, we're doing interval notation, not set. I'm using a parentheses because we've got these open holes at the beginning and end here, which means that it goes up to that point, and I mean it goes up to negative 4.999999999 for infinity, but the second it gets to that negative 5, it stops. So this graph starts, though, on the left at this negative 5. And then it keeps going up to positive 4.9999, but once it gets to this 5, it stops. So we've got that going on for our domain. Now in our range, we care about our y values. Again, it's the same chunk of line, but instead of how far left and right it goes, we care about how far up and down it goes. So it starts down here. We always start at our negative values, left in x and down in y. So it starts down here at negative 3. Again, we have those open circles, so we use parentheses. And then it comes up and it stops at this point where y equals 2. So we've got that. Any questions about that? Alrighty, well, I'm going to go ahead and give you guys a few seconds to work on the practice problem for this. And I'll be back to you in about 30 to 45 seconds. Feel free to post any questions. Does anyone need any more time on that one? If you could just throw a Y or an N in the chat box for me, please. All right, let's just review real quick, make sure we all got the same answers. Again, in domain, we're going to look at our X values. So where it starts on the left and goes to on the right. So our domain, wow, that was horrible. Let's see if I can do a little bit better than that. There we go. Our domain is going to be where we start on the left, and in this case, since we have this closed-in circle, I'm going to put it in a bracket. And we start at x is equal to -4. And then we keep going up on the right to this point where x equals 2. And since that's an open circle, it gets a parenthesis. Our range for this one is going to be our y values, where we start down here at the bottom and come up to here where it stops at the top. So our range is going to start at y is equal to -5, right down here, and come up to where y equals +2, which of course gets the parenthesis. Is that what everyone else got? All right, good deal. Let's jump on to number 5 here. The functions f and g are defined as follows. where f is equal to 4x plus 2 and g is equal to 3x cubed plus 5. Find f of negative 6 and g of negative 2. What that's saying is that, hey, we've got this function up here of f that's written in terms of x. And instead of this x, we want to use negative 6. So everywhere in this function f that we see in x, we're going to plug this negative 6 in. So the f of negative 6 is going to be equal to 4. And something I really like to do, and I try to get my tutorees to do this, tutees to do this, whichever, I'm math, not vocabulary. I always like to put parentheses anywhere I see an x, and that really comes into play later, especially you'll see with that g function where you're getting it cubed and being multiplied on something. But and anytime you have multiple x's in the equation, this really just helps you to see what's going on and make sure you're doing everything that needs to be done. So we're going to do 4 times our x plus 2. Well, 4 times negative 6 is going to be negative 24 plus 2. So our f of negative 6 is equal to negative 24 plus 2 is negative 22. For our g function, we're going to do g of negative 2. That's going to be equal to 3 times my x, which is negative 2 in this case, cubed, plus 5. And our order of operations says that we need to deal with this exponent up here first. So we have negative 2 cubed is going to be negative 8. So I have 3 times negative 8 plus 5. 3 times negative 8 would be negative 24 again, plus 5. So my g for negative 2 is equal to negative 24 plus 5 is negative 19. Are there any questions about that? All right, we'll go ahead and throw up the practice problem on this one then. I'll give you guys about a minute to a minute and a half to work through these two, and I'll come back and check on you. Feel free to throw any questions you have into the chat box. All right, would anybody like some more time for this one? All right, let's go ahead and work through it real quick then. So here we're given the functions f and g as follows. F is negative 2x cubed minus 5. G is negative 2x minus 1. Find f of -4 and g of 5. So our f for -4 is going to be -2 times our x, which is -4, cubed minus 5. -4 cubed, -4 times -4 is +16, times another -4 would give us -64. So we have -2 times -64 minus 5. A negative times a negative will yield a positive number. So 2 times 64 is going to be 128 minus 5. So f of -4 is equal to 123. For our g of 5, we have our original function is -2 times x. So I'm going to pop that parentheses with the 5 in it, and -1. -2 times +5 will give us a -10 minus 1. And then our g of 5 is going to be -10 minus 1, so -11. Everyone else get the same thing? All right, let's jump into the next one. Great, this one, no real work involved. Just watch, and I take it back. There will be drawing vertical lines involved. So if you have a hard time with that, this might get tricky. Aside from that, this is a pretty easy thing to deal with here. So I'm actually going to use this function over here. For each graph below, state whether it represents a function. The way we tell whether or not something represents a function when it's graphed like this is we do what's called the vertical line test, where we just draw vertical lines at random places and see if that vertical line that we drew hits the graph in more than one place. If it hits in 2 places, it's not a function, because the definition of a function is that for each x value, there's one and only one y value. There's a few other definitions of functions, but that's the one that we're primarily concerned with in this example. The tricky point in this first one is right over here, where if I draw a vertical line, it looks like it's going through 2 places at once. But it's really not going through this place right here, because we have to remember that this open circle means that it doesn't actually connect at that point. So it's okay that that open circle and the closed circle are on the same vertical line there. Because everywhere else that we draw a vertical line, and I realize it's not perfectly vertical, I'm sorry about that. Challenge with technology here. Everywhere else that we can draw a vertical line on this graph, there's only one place where it goes through. And at this point, it's really only going through at one point, because there's only one filled in spot here. So this one is a function. Whoops. About these brushes, and there we go. Over here, I can draw a vertical line. Yeah, I like that other tool better. Draw a vertical line. But over here, when I draw a vertical line, it goes through 3 dots at once. Okay, right in there. So this one is not a function. It didn't pass our vertical line test. The vertical line went through 3 different places. Again, over here, it doesn't matter where I draw my vertical lines. I can only get them to 1 point at a time. So that one's a function. Again, no matter where I draw my vertical lines on this graph right down here, it only goes through the graph at 1 point, here and here, for each one of those lines. So that one's a function. Now for this next graph, if I draw a vertical line going right through here, my vertical line passed through the blue line twice, once here and once here. So this one is not a function. And the same thing with this last graph on the right here. I can, do a little better example. Draw it right there. My vertical line goes through this blue line at the top of the circle and the bottom of the circle, so that one's not a function either. Does that work for everyone? Make sense? All right, let's go ahead and pull up the practice problem for this one. Again, this one's a little bit quick here. I'm going to just give you guys about 30 seconds or so to work on it, and feel free to type any questions you have into the chat box. All right, would anybody like some more time for this? Okay, so let's go through it real quick. The first one on the top left, if we draw our vertical line over here on the left, we can see that we're going to go through, whoa, where'd that line go? There we go. We can see that we're going to cross our blue graph twice, once here and once here, so this one is not a function. Over here, no matter where I draw my vertical line, it only goes through the graph once. So this one's a function. Over here, though, in this triangle, I put a vertical line. I can put it on the left or on the right. I'm going to cross through this triangle twice. So that one is definitely not a function. And this graph on the bottom left here, I can draw a vertical line going right through these 2 points, as well as going through these 2 points. And since that one vertical line is crossing through 2 points, this one is not a function. And this one in the bottom middle here, despite the fact that it's going through that closed circle and the open circle and this closed circle and the open circle, again, this closed circle is the only one that actually counts in that sense. So this one actually is a function. Then again, on this bottom right graph here, no matter where I draw my vertical line, I only go through each point once, or the vertical line only goes through 1 point on each one. So that one is a function. Does everyone agree with that? All right, let's go on to our last problem for the night then. So here we have a nice application problem. I love application problems. It's why we do math. Who cares about all these stinking numbers if you can't actually use them? Suppose that the weight in pounds of an airplane is a linear function of the total amount of fuel in gallons in its tank. So this is going to be kind of like number 2. I think it was number 2. When graphed, the function gives a line with a slope of 5.5. See the figure below. With 52 gallons of fuel in its tank, the airplane has a weight of 2,286 pounds. What is the weight of the plane with 27 gallons of fuel in its tank? So this one is a lot like number 2, except they were kind enough to just go ahead and give us that slope of 5.5. So we have even less work to do. Isn't that wonderful? Again, we're going to use that point slope formula where we have the point of 52 gallons gives us a net weight of 2,286 pounds. So y minus our y1, I'll go ahead and write it out, is equal to m times x minus x1. And they gave us the n is equal to 5.5. So we can plug our numbers in here where we have y minus 2,286 equals m times x minus x1, oops, times x minus 52, because 52 is our x1. And they already gave us our x value as well that we need to solve for, which is this 27 right over here. So we have y minus 2,286 is equal to m times 27 minus 52. Y minus 2,286 equals, oh, m, again, m they gave us is 5.5. This is the last one. I can't make too many more mistakes, right? 27 minus 52 will yield a negative 25. I want a calculator for that one. 5.5 times negative 25 is going to give us negative 137.5 on the right side there. If I add this 2286 to both sides now, I will find out, oops, that when we have 52 gallons, or I'm sorry, when we have 27 gallons of fuel, the weight of the plane is going to be 2,148.5 pounds. Where is my pointer? There it is. 2,148.3. All right. Does anybody have any questions about that? All right. I'm going to go ahead and throw up the last practice problem here. Let you guys work through it. I'll be back in a minute or two. Well, 1 minute since we're almost done out of time here. But let me know if you have any questions. All right, is everybody ready for me to work through this last one? All right, let's get cracking then. So suppose that the monthly cost of a long-distance phone plan is a linear function of the total calling time in minutes. What that means is that for however many minutes you use, your cost is going to go up. Unless you have a really awesome plan and it goes down, then let me know because I'm looking. When graphed, the function gives a line with a slope of 0.13. See the figure below. The monthly cost for 33 minutes of calls is $16.25. So we've got our X is the number of minutes because that's what we're counting. So 33 minutes yielded a cost of $16.25. This guy needs a better plan. What is the monthly cost for 36 minutes of calls? So we're going to use that Y minus 16.25 is equal to our slope they gave us. I'll go and write that down as 0.13. So 0.13 times X minus 33. And they gave us the X to start with is going to be 36. So Y minus 16.25 is equal to 0.13 times 36 minus 33. or y minus 1625 is equal to 0.13 times 3. So y minus 1625, 0.13 times 3 is going to be 0.39. If I add 1625 to both sides, there you go. We find out that his cost when he used 36 minutes is going to be $16.64. Does anyone have any questions? All right, well, thank you for putting up with my tired self cranking through all these. Hopefully this was helpful to you. We will see you on Wednesday with some new questions, and have a great night, everyone. Feel free to stop by ASC anytime.